Good evening and welcome to the session number 19 from the chapter of alternating current. The topic is the average value of alternating current in one complete cycle. Now today we will be proving mathematically that the average value of alternating current in one complete cycle is equal to 0. So the alternating current is given by I is equal to I naught sine omega t, where I naught is the peak value of the alternating current. Now if we assume that assuming that the current is constant, in a very small time, in a very small time interval, say dt. Assuming that the current is constant in a very small time interval, say dt, the charge flowing through the circuit in the time interval dt will be given by dq will be equal to I dt, and here I is equal to I naught sine omega t, so dq will be equal to I naught sine omega t dt. So the total charge through the circuit in one complete cycle this will be given by that is, I will simply integrate this equation within the limits of 0 and t. Here t is what? T is the time period of the alternating current. Time period is what? It is the time taken to complete one complete cycle. So this will be equal to I naught sine omega t dt. So here Q, that is the total charge which will be flowing through the circuit in one complete cycle, this will be equal to Q will be equal to this I naught is a constant, so this will be taken out and I will be left with the integration within the limits of 0 and t sine omega t dt. Now this will be equal to I naught, the integration of sine omega t will be equal to minus cos omega t divided by omega within the limits of 0 and t. So this can further be written as I naught. Now I naught divided by omega, and this will be minus cos omega t within the cos omega t within the limits of 0 and t. So from here, now omega is equal to 2 pi upon t, where t is the time period. So this can be written as I naught divided by 2 pi upon t. So this will be I naught into t divided by 2 pi, and this will be, now omega is equal to 2 pi upon t. So if I substitute this value, so this omega t will be equal to 2 pi upon t into t. Now if t is equal to t, small t is equal to t, then omega t will be equal to 2 pi upon t into t. So this will get cancelled out. So finally I will be left with minus cos 2 pi and minus plus cos 0. Now the value of cos 2 pi is equal to 1. So I will be getting I naught t upon 2 pi, and this will be equal to minus 1 plus 1. So this is equal to, this will be equal to 0. So finally I am getting the value of the total charge which will flow through a circuit in one complete cycle. This is equal to 0. So the average value of alternating current in one complete cycle, this will be equal to Q upon capital T, where T is the time period, and this will be equal to 0. 0 because the total charge which will be flowing in the this AC circuit in one complete cycle, this is equal to 0. So the average value of the alternating current in one complete cycle will be, which is equal to Q upon T, where T is the time period. Since Q is equal to 0, so I will be, that is the average value of alternating current in one complete cycle will be equal to 0. So in the next session I will be discussing, or I will be discussing the derivation between, or you can say I will be discussing the relationship between the peak value of this alternating current and the average value of the alternating current. In fact, we will be deriving the relationship between the peak value and the average value of alternating current in the session number 20. Till then, have a nice day. Bye.